Hi lads, it's Danny here today, bringing you a lovely video. In today's video, we're going to take a look at how to solve definite double integrals. So the way to solve these it's pretty straightforward. It's not difficult, but there's more steps to it. So I'll show you how to do it. But before we jump into it, I want you to leave a like and subscribe. So the idea here, the trick I like to show you is when you're doing a double integral problem, even triple integral, right, you're going to have to consider one integral at a time. So what do I mean by that? So judging here, we have two integrals. So I'm going to look at the inner integral. That's the key over here. And in this case, the inner integral is this, which is basically, if you don't see anything inside the integral, it's basically 1. We can consider it as 1. And we are taking the integral from x to the power, x plus 2 as lower bound, and the upper bound is cos of x. Therefore, we are going to take an integral of basically 1 dy. So let's rewrite it in a more familiar format. So we're considering this integral. So the idea here is we do one integral at a time. So we're going to consider the first portion of this integral. So we are integrating according to y. Therefore, it's basically a very standard integral to solve. You're just doing the integral of 1 dy, and you are going to end up with y. And notice, since this is a definite integral, you are going to have your upper and lower bound, which you are going to have to subtract, really, according to the laws of calculus, fundamental theorem of calculus. So therefore, you're going to basically, since you know it's equal to y, you are going to replace the upper bound where the y is located and subtract it with the lower bound. So when you do that, you are going to have cos of x minus open bracket x plus 2 close bracket. So we can basically distribute the negative and we'll be left with this. So right now what we've done is we have solved for the inner integral. Now we got to proceed and solve for the entire integral, basically the outer integral, which is the integral of 0 to pi. So we are going to basically substitute what we solved in the first inner integral, and we're going to basically replace it in the outer integral, really, right? So we know that it's going to be equal to this. Once you have done that, you're basically going to, this is the resultant of this integral, which is written right here. So we are then going to proceed and take an integral, very straightforward. You are going to have to take the integral of cos of x, and then negative x, and then negative 2, which is very straightforward. So we're going to do that. So when you take the integral of cos of x, it's going to be sine of x. Here it's going to be subtracted with x squared divided by 2 minus 2x. And then since it's a definite integral, we're going to have an upper and lower bound. So we are going to basically replace pi inside this equation and 0. And they're going to be subtracted, really, right? So we can rewrite the answer over here. And from here, let's just simplify it so it's easier for us to get a final conclusive answer. So sine of pi is equal to 0, and all this over here is going to cancel out because it's just equal to 0. What you are going to be left with is negative pi squared divided by 2 minus 2 pi, and this is the result of this double integral. So if you enjoyed this video, and if this video has helped you understand how to solve a double integral, please drop a like and subscribe, and I'll see you later.